What is a decimal number? A decimal number is a value that includes part of a whole. Think about dollars and cents. Tomatoes cost $1.25. But what does this number mean? The 1 represents $1. The 25 represents cents. We know that the price is more than $1, but less than $2. This means that 25 cents is part of a dollar. There are 100 cents in $1. What part of a dollar is 25 cents? The dollar is the whole. The cents are part of the whole, and the entire value is a decimal number. The whole and the part of a whole in a decimal number are separated by a decimal point. That decimal point isn't just for decoration. A decimal is a point used to indicate position or place value. All the digits to the left of the decimal point show a whole, and all the digits to the right show part of a whole. This Great Dane is 76.5 centimeters tall. But what does this number mean? Think about measurement and the metric system. This is a meter stick. It measures 1 meter. It measures decimeters. It also measures centimeters and millimeters. This example uses centimeters, so we will focus on centimeters first. The dog is smaller than 1 meter. He is taller than 76 centimeters, but is smaller than 77 centimeters. The 5 in the number is part of a centimeter or millimeters. There are 10 millimeters in 1 centimeter. The 5 represents 5 millimeters, which is halfway between 76 and 77 centimeters. The centimeter is the whole, the millimeters are part of the whole, and the entire value is a decimal number. The other unit of measure that is common for measuring height is meters. If we measure the Great Dane using meters, the whole would be in meters, not centimeters. He is still less than 1 meter, so we will use the digit 0 to represent the whole. Let's count to see how tall the dog is. The Great Dane is 765 millimeters, or 0.765 meters tall. How tall is the dog? 76.5 centimeters and 0.765 meters. Both of these numbers are decimal numbers. They represent a whole and part of a whole. In the first measurement, 76.5 centimeters, the whole is centimeters and the part of the whole is millimeters. In the second measurement, 0.765 meters, the whole is meters and the part of the whole is still millimeters. It is the same dog with the same height, but the height is described using different units of measure. Our number system is a base 10 system. What does that mean? Look at the meter stick again. 1 meter is equal to 10 decimeters. In each decimeter, there are 10 centimeters. That means 10 groups of 10 in the meter stick, or 100 centimeters. In each centimeter, there are 10 millimeters. That means 100 groups of 10 in the meter stick, or 1,000 millimeters. When there is a pattern of increasing or decreasing by groups of 10, it is a base 10 system. We can use place value to understand the base 10 pattern in our number system. The ones column refers to individual units. When a group of 10 is counted or created, we can use another column to organize the digits of the number. 10 ones is the same as 1 group of 10 and 0 groups of ones. 10 groups of 10 is equal to 100. We can say it is 1 group of 100, 0 groups of 10, and 0 groups of ones using the columns to organize the digits of the number. The patterns in whole numbers can be applied to decimal number place value. We will focus on digits to the right of the decimal point, which show part of a whole. This large cube represents 1 whole. It can be separated into 10 flats. The column to the right of the decimal point means out of 10 and is called the tenths column. Each flat can be separated into 10 rods. This makes 100 rods, or 100 parts of the whole unit cube. This column means out of 100 and is called the hundredths column. Each rod can be separated into 10 small cubes. This makes 1,000 small cubes, or 1,000 parts of the whole unit cube. This column means out of 1,000 and is called the thousandths column. We use a base 10 number system. Each column to the left has a value that is 10 times greater than the column to its right. And each column to the right has a value that is 10 times smaller, or 1/10, or divided by 10, compared to the column to its left. Remember, the decimal point isn't just for decoration. A decimal point is used to indicate position or place value. The decimal point separates the whole and the part of a whole. In decimal place value, when we move to the right of the decimal, the numbers are a smaller part of the whole. It is important to know that the place value system can go on to the left and the right forever. Here are the decimal numbers from our examples. Where do they fit in the place value chart? The first example used $1.25. $1 is the whole, and the 25 cents is part of a whole dollar. The value ends in the hundredths column. This is because we have 25 out of 100 possible cents. When we name a decimal number, we use the last place value column. We use the word "and" to indicate when a value includes a decimal point. This number is 1 25/100ths. The second example used 76.5 centimeters. 76 is the whole, and 5 is part of a whole centimeter. The value ends in the tenths column. This is because we have 5 out of 10 possible millimeters. This number is 76 5/10. The third example used 0.765 meters. 0 is the whole, and 765 is part of the whole meter. The value ends in the thousandths column. This is because we have 765 millimeters out of 1,000 possible millimeters in 1 meter. This number is 0 765 thousandths. If a number is less than 1, we don't need to say the 0. We can say 765 thousandths. Another way to think about decimals is where they are placed on a number line. Decimal numbers include part of a whole. They are positioned in between the whole numbers on a number line. You can keep zooming into the number line and dividing each space into smaller pieces of the original whole number section. Think about the example values 1 25/100ths, 76 5/10ths, and 765 thousandths. Where can these be placed on the number line? 1 25/100ths is larger than 1, but less than 2. Divide the space between 1 and 2 into 10 equal parts. 1 25/100ths is in between 1 2/10ths, or 20/100ths, and 1 3/10ths, or 30/100ths. Divide this section into 10 equal parts, and we can see the number 1 25/100ths would be in the middle of 1 2/10ths and 1 3/10ths. 76 5/10ths is between 76 and 77. Divide this section into 10 equal parts. 76 5/10ths is exactly halfway between 76 and 77. 765 thousandths is less than 1. Divide this section into 10 equal parts. The number will be more than 7/10ths, or 70/100ths, or 700 thousandths. The number will be less than 8/10ths, or 80/100ths, or 800 thousandths. Divide this section into 10 equal parts. 765 thousandths is between 76/100ths and 77/100ths, and the number is in the middle of 76/100ths and 77/100ths. It is also possible to have negative decimal values. To review, decimals are values that include part of a whole and are shown with a decimal point. We can use a place value chart to help organize the digits of a decimal value by using the columns to the left and right of the decimal point. The hundreds, tens, ones, tenths, hundredths, thousandths, and so on. We use a base 10 number system. The value in each column is either 10 times smaller or 10 times larger than the column next to it. When using decimals, it is important to think about the entire value. The whole and the part of the whole work together to form a single value or decimal number. Watch this video again, or others in this video series if that might be helpful, and talk to your teacher if you have any questions.